Welcome to CE 405 Environmental Engineering 1 Module 3 Part 8. In this session, I am going to discuss our third problem which I had already given in the Part 5 session. The question is, design a coagulation cum sedimentation tank with a continuous flow for a population of 60,000 persons with a daily per capita water allowance of 120 liter and make the suitable assumptions where needed. The only two factors that is given in this question is the number of persons and the per capita demand. By using these two factors, these two values, we have to design a sedimentation cum coagulation tank. For this, first we have to calculate the average daily consumption. What is an average daily consumption? It is the number of persons into per capita demand. Here it is 60,000 into 120. That is we get 7.2 into 10 raised to 6 liters. Then we will move on to the maximum daily demand. What is a maximum daily demand? It is the 1.8 times the average daily consumption. Then we will get 12.96 into 10 raised to 6 liters per day as maximum daily demand. This is per day. Then the first assumption, that is the detention period. Detention period of sedimentation tank. That is, here it is 2 to 4 hours. For a sedimentation cum coagulation tank, we are going to assume the detention period in between 2 to 4 hours. Here we are taking the detention period as, assuming the detention period as 4 hours. The second assumption is the overflow rate, that is the surface loading rate, which should be in between 1000 to 1250 liters per hour per meter square of tank area. That is, here we are going to assume the overflow rate as 1000 liters per hour per meter square. Then, what is an overflow rate? Overflow rate, mathematically we can express it as Q by BL. That is the cross-sectional area. That equal to 1000 liters per hour per meter square. Then quantity of water to be treated in 4 hours. Because our detention period we already assumed as 4 hours. So we have to calculate the quantity of water to be treated in 4 hours. Here the value we have already obtained is maximum daily demand, that is the per day demand. So we have to calculate it for per hour demand, that is 12.96 into 10 raised to 6 divided by 24 will give you the per hour demand of water. Then into 4 will give you the quantity to be treated in 4 hours. That is, we will get a value of 2.16 into 10 raised to 6 liters. Then convert it into the cubic, that is in meter cube. Divided by 1000, we will get 2.16 into 10 raised to 3 meter cube. This is the quantity of water to be treated in 4 hours, which is the capacity. Then we have to calculate the Q value then. What is the Q value? Which is this is for the per day, that is the detention period of 4 hours demand. Then we have to calculate it for per hour. That is divided, 4 hours is our detention period. So we have to divide the quantity of water to be treated in 4 hours divided by 4 will give you the quantity to be treated per hour. 2.16 into 10 raised to 6 divided by 4 liters per hour. This is per 4 hour. That is the quantity to be treated in 4 hours per 4 hour. This is in liters per hour. That is, the value is 540 into 10 raised to 3 liters per hour. Then the next assumption, the third assumption is use the width of the tank as 12 meter. That is breadth into length from the overflow rate equation, that is Q by BL. We can rewrite it as BL is equal to Q divided by 1000. Then we get the value of cross-sectional area as 540 meter square. Then we are assuming the width as 12 meter. Then we will get the length as 45 meter. Then we will get all the dimensions of the tank, sedimentation tank. Dimensions of the sedimentation tank, that is 45 meter length, 12 meter width and 4 meter depth. Then we are again assuming, that is our fifth assumption, sorry, it is fourth assumption, that is assume a bed slope of 1 in 50. We have to provide an extra depth for sludge storage. What is a sludge storage? It is a sedimentation tank, so that all the impurities or flocks, the sediments are deposited in the inside the tank. Then a portion of the depth will be filled with these sediments. So we have to provide an extra depth for storing these sediments. That is, an extra depth for sludge storage at the starting we have to provide a 0.5 meter. So 4 plus 0.5, that is 4.5 meter depth will be at the starting of sedimentation tank. Then at the end we have to calculate the depth at the end. Already we have assumed a bed slope of 1 in 50. Then at the end we are going to calculate the depth as 4.5 meter as at the starting plus 45 meter. What is this 45 meter? This is the length of the tank divided by 50. Then we will get a 5.4 meter depth at the end of sedimentation tank. Then we have to provide a freeboard. What is a freeboard? Above the water level, in order to avoid the overflowing and excess water mixing, we have to provide a freeboard of 0.5 meter above the water level. Here the depth is 4.5 meter at the starting and 5.4 meter at the end, and above the water level we have to provide a freeboard of 0.5 meter. Then this is the design for a sedimentation chamber. Then we have to design the floc chamber also, where the flocculation happens. Then design for floc chamber. Here the assumption, fifth assumption comes and the sixth assumption. The first assumption is effective depth of the floc chamber. Effective depth of the floc chamber should be depth divided by 2. Depth of the sedimentation tank divided by 2. What is the depth of the sedimentation at the starting end? Which is 4.5 meter. This 4.5 meter depth will be at the end of flocculation chamber. That is, the sedimentation chamber will be constructed immediately after the flocculation chamber. So the water depth or the total depth of sedimentation tank will be 4.5 meter at the ending of flocculation chamber. So we have to adopt a depth of 4.5 meter here. So we will get an effective depth of floc chamber as 4.5 meter divided by 2, that is 2.25 meter. Then the next assumption is the detention period of floc chamber. Theoretically, the detention period will be should be in between 15 to 40 minutes. Here we are going to assume it as 20 minutes. Next we have to calculate the capacity of the tank. What is the capacity of the tank? It is the flow required in 20 minutes. 20 minutes is the detention times that we had already assumed. Then the capacity of tank is equal to what is the flow? That is 12.96 into 10 raised to 3 divided by 24. That will give you per hour flow. Then into 20 minutes will give you the flow in 20 minutes. Even though all the parameters are in hours, we have to convert this into hours. Then divided by 60. That will give you the capacity of the tank, that is 180 meter cube. Then the plan area required. Plan area required for the flock chamber. That is capacity divided by the depth. Depth we have already calculated, that is 2.25. Then capacity it is 180 meter cube. Then 180 divided by 2.25. We get the plan area required as 80 meter square. And this flock chamber is constructed immediately before the sedimentation tank. Then the width of the flocculation chamber will be same as that of sedimentation tank. We have already calculated, we have already assumed the width of the sedimentation tank as 12 meter. So we are going to calculate the length of the flocculation chamber, that is 80 divided by 12. Then we will get a value of 6.67 meter. Then we are adopting a value of 6.7 meter as the length of the flock chamber. By finding the length of the flock chamber, we completed the design of flock chamber. And already we have completed the design of settling tank or sedimentation tank. Now we have to move on to the sketching of sedimentation cum coagulation tank. First we designed the settling tank or sedimentation tank with assuming a depth of 4 meter at the starting end, that is the water depth, and we have calculated the length of sedimentation tank as 45 meter, and at the starting end of sedimentation tank the total depth should be 4.5 meter by providing an extra depth of 0.5 meter for sediment storage. And at the end of this 45 meter length tank, the total depth should be 5.4 meter that we already calculated. That is by providing a bed slope of 1:50. Here 4 meter will be the water depth and 1.4 meter will be the sediment storage. And there should be an outlet arrangement for collecting the purified water, and here there will be a drain wall for collecting the sediments from the bottom of the sedimentation tank. And an extra freeboard of 0.5 meter is provided above the water level. Then the flock chamber part, the depth of the flock chamber is 2.25 meter and the length of the flock chamber is 6.7 meter. Then the total depth of this flock chamber come the inlet distribution channel arrangement will be 4.5 meter. Then this is the inlet arrangement from where the water coming from the mixing basin is entering into the sedimentation cum coagulation tank through this inlet arrangement. From the inlet arrangement, the water is entered into the distribution channel from where the water is evenly distributed in the flock chamber without disturbing the flow pattern in the flock chamber. And the water is entered into the flock chamber from where the flocks are formed, and from this the water is entered into the settling tank from where the flocks are deposited, that is the sediments are deposited and the sediments are collected through this drain wall, and the purified water is collected through the outlet. This is the basic schematic representation of sedimentation cum coagulation tank. After designing a sedimentation cum coagulation tank, you have to draw this schematics sketch. Otherwise, the problem will not be completed. So, I hope you all understood the designing part and the sketching part. And if you have any doubts, please go through the textbook also. And thank you for listening. Take care. Bye bye.